Firstly, I've got to thank you personally for coming to a security session last thing in the day. You are clearly all quite keen on security. I mean, it's quite hard to get people to security sessions at 10 o'clock in the morning, never mind at 4, so well done for coming. My name is Eoin Woods. I'm the CTO of a company called Endava. I'll tell you about us in 30 seconds in a minute, but we're going to talk about security, but particularly application security, because most people talk about network security most of the time, and we're talking about a particular set of, a particular framework for it called the OWASP Top 10. I'm CTO at a company you will never have heard of called Endava. We're about 5,000 of us, and we span Europe and the Americas. And our furthest eastern delivery center is in Moldova, and our furthest eastern client, I think, is Bank of Transylvania, which is the largest bank in Romania. And then we have clients right across to the West Coast, where we serve large product companies. I've done products and applications my whole career, so I'm completely kind of software person. I'm not a network infrastructure person, and I'm not a security engineer. And that's quite important because you get quite a lot of security talks from security engineers who are basically infrastructure guys. And they know what they know really well, but they don't know very much about building software. And they find us a bit annoying, if I'm going to just break that truth to you, because we don't necessarily see security as the only thing that the software needs to do. Whereas if you're basically a networks and infrastructure security person, the only thing the software has to do is be secure. And that's your perspective on it. So that's why I give these talks, because I have actually worked in secure systems development. I worked in digital rights management for a bit and suddenly realized how much I didn't know. And building system software products, places like Sybase, I worked very closely with security engineering. And then it dawned on me at that point, there was the security world, and then there were the rest of us. And in the middle, there was what one of my colleagues amusingly refers to as the desert of responsibility, where clearly that's not my problem, it's security's problem. And security going, clearly this isn't our problem, that was software engineering's problem. And that's why software products are full of security defects. So I am personally, and a small number of other people I think in the industry, trying to bridge that gap. And this talk's one of those. So we're going to just very briefly talk about why we care about software security and what threats are, and an organization called OWASP. Let's just kind of get the knowledge in the room. Who is a security engineer, having just slagged them off? Thank goodness for that. That's a better start than I was hoping. That's the second or third time I've asked that question at the wrong moment. And 4 hands go up. I think, oh, I've not made any friends there, have I? So who here works in secure systems? Does anyone work for one of the big defense contractors? Yeah, great. And who builds web applications? At least some of the time? Great. And who's heard of OWASP and is aware of the top 10 list? Super. So some of this will be familiar, and hopefully some of it will at least be a good refresher. So why do we care about security? This is something that often security engineers very understandably lose sight of. It's a bit like if your mums or your wives or whoever said to you, why is it we need software? You'd look at them blankly and you go, well, it's my life. That's why we need software. If you're a security person, it's the only thing that matters. But sometimes you need to just once again remind ourselves why it's important. And it's because we need dependable systems in a world where there are malicious people, things go wrong, and people make mistakes. In other words, some people are bad, some people are stupid, and some people are just a bit unlucky. And security is about all of those, not just the bad people. And there's often an emphasis just on the bad people. Whereas, you know, there's plenty of unlucky people to go around. I've been involved in a few all-night production incidents when I worked in banking, directly caused by people who were a bit unlucky with a very small amount of stupidity mixed in. There's plenty of that around. And in every case, when we looked at how we could have stopped it happening, we nearly always went, you know, if we'd thought for 10 seconds about the security model, that shouldn't have been able to happen. And we talk about security threats, and those of you who work in secure systems, this is very old hat, but actually, for those of us who don't work in secure systems, we're worried about what the threat to the system is. And again, they're much broader than most of the threats most people think about. It's things like, does somebody want to steal something? Does somebody want to defraud someone else? Does somebody want to destroy something? Or does somebody want to disrupt something? Normally, to gain some kind of advantage, some kind of value. And it's key thing for focusing our security attention, because there's always too much to do, is focus on the stuff that other people may find of value. That's how we know where to go and look for security. It's like the apocryphal quote about the bank robber when the judge says, why on earth do you keep robbing banks? And he says, because that's where the money is. Same for attackers. They're attacking for a reason. It may not be a very conventional, straightforward reason, but they're attacking for a reason. And we care about this because nearly all of these threats result in a loss, not just of money, though, and we nearly always think about money. It could be a loss of time. It could be a loss of privacy, Facebook. It could be a loss of reputation, Facebook. It could be a loss of advantage. So, for example, people attacking auction sites. It used to be quite a cottage industry in the early auction sites, attacking auction sites to make sure that you can prevent the other people bidding against it. What's the most trivial attack against an auction site? A web-based auction site. It's an absolutely obvious one. You'll all know it as soon as I tell you. Well, that's a very large-scale one. If you want to target a particular bidder, there's a very straightforward way to do it.
Bidding bot?
Yes, though. Yes, you could use a bidding bot. That's a decent attack, but there's an even simpler one. What happens on most websites if you type in the password wrongly 10 times quickly? It tends to lock the account. When it's locked the account, what's the next thing it does? It validates all the sessions. What happens to the person who's just bidding right now, 60 seconds before the deadline? They're going to go through a password reset. And how long will that take? About 75 seconds. Oh, damn, they're out. It's a very, very simple, straightforward attack, but it's very effective if the auction site security engineers didn't think of it first. And that's why security is hard, because thinking about all the ways adversaries can attack you is difficult. And that's why things like the OWASP Top 10 are tremendously valuable, because they give us frameworks and checklists based on real data. The reason that actually I think this is quite urgent now, and I've been talking about this for about 3 years, and if anything, the risk, unfortunately, I'm not becoming hysterical, but the risk is going up quite sharply, is that everyone's talking about digital channels. I mean, we do it in Dava quite a bit. We talk about digital solutions, agile, and automation. Digital's a big thing for us, and it's about putting digital channels often into businesses who've been around quite a long time, which typically involves hanging an API on the internet, which sounds like a terrific idea unless you're a security engineer who just look at you as if you're absolutely insane. Why would you do that? Well, because that's how we create a digital channel. But that's also how you reveal your API to everyone else in the world, including a whole lot of people with time on their hands in China. That doesn't sound like a great security decision, so there's a big trade there. It's also, we're now making our APIs much easier to introspect. Hubert Matthews was talking about REST in the last session. Lovely thing about REST is that you don't even need computer sophistication to work out what the API is. You just ask the API, and it ponies it up in JSON for you. You almost can't miss it. The other thing that's happening is that attacks used to be the domain of skilled people, people who really knew about stuff, especially in the age of binary protocols. And generally, there were quite small, closed communities of people who knew this stuff. And this was the kind of thing that security engineers worried about, was that there were small numbers of highly skilled adversaries. You can now, you don't even need to use the dark web. I think 4 or 5 years ago, people talked about the dark web. You can find this stuff on just normal websites. You can find attacks that have been weaponized, as they call them, meaning made idiot-proof. You can now have a 15-year-old in wherever, doesn't matter which country actually, it could be in any country, in France, who decides that just for laughs, they're going to attack your website with a denial of service attack. Well, that wouldn't have been credible 10 years ago, whereas now they can actually go and buy a botnet for a couple of hours for a very affordable number of Bitcoin. That's a pretty worrying thing. Has anyone here come across SQL map? The security engineers will have, yeah. So SQL map's an example. I'll show you it later. It's quite concerning, actually, when you run SQL map on your own system, how straightforward it is. And the thing that we keep finding is that today's internal application, do you ever have those conversations about it's an internal app, therefore it's got different security requirements to an externally facing app? That's entirely the wrong conversation. Can I just kind of give you that hint now? Because most of those internal apps, or many of them, are becoming tomorrow's digital channel, or they're becoming accessible from the digital channel. So that's why I think this is quite serious, and the threat is growing all the time. So there's an organization who's been around a lot longer than digital channels called OWASP, and they are specifically interested in application security. And as I say, in the security world, there's not that many people are, relatively speaking. They're a completely volunteer organization, and they're pretty virtual. I mean, it really all just happens online. They've got a big wiki with a lot of collaboration, and there are local chapters. And their only reason for existing is to help people like you and I improve our application security. And they do research. That's where the top 10 comes from. They build practical tools. I'll show you one of them later. They provide very useful guidance, and they're starting to actually get involved in writing formal standards. They also run local chapters, I don't remember if there's one in Bristol, but then I guess you've all travelled here from many places, so it doesn't really matter. There are chapters in a number of cities in the UK, and there are hundreds of chapters worldwide. And they're just effectively, they're the meetups before the meetup era. They're a group of people who are really interested in application security. One of the things they did back in the early 2000s was they realised that their members, who were application-level security engineers, were seeing the same problems in web apps again and again and again and again. And they realized the best thing they could do was to point out to everyone that we were being repetitively stupid. We weren't being creatively stupid in clever ways. We were doing the same dumb things over and over and over again. So they largely at that point, largely anecdotally, did a big survey of their members and said, what dumb things do people do all the time? And a number of themes came out, and they refined that into a list of the top 10 things to worry about. And then the following year they said, oh, I wonder if it's the same. And web technology was moving quite fast then, so they said, it's not quite the same, we'll issue it again. And then 2007, some bright spark said, we should have another look. And they said, yes, things have moved, so they issued it again. And then 2010, 2013, and last year, 2017, they have issued new versions of the list. I'll show you the diff between the last two in a few moments, but the really scary thing is that stuff on the 2003 list is still on the list today. Before you tell me you know about SQL injection and nobody does that anymore, it's still number one on the list, quantitatively, as measured by the web security companies. So, people are still making these mistakes all the time. There are a couple of other people it's worth being aware of, if you haven't come across them. If you work in defense, you'll undoubtedly have come across MITRE. They run the Common Vulnerabilities and Exposures database, which is the standard industry place that when you find a vulnerability in something, you go and get a unique ID and you describe it there. And MITRE do a tremendous job in producing a database of those. If you've used open source scanning tools, it's the CVE database they're all referencing when they tell you you've got potential vulnerabilities in Apache Commons or something like that. And then SafeCode, I find most people haven't heard of SafeCode. They're an organization created by a relatively small number of very big, powerful software companies who were a bit concerned about application security. And they also noted that they all really had the same needs. They needed training, they needed champions, they needed people, they needed good quality information. And so they created a consortium to do that. And they in particular have created free online, fairly high quality webinar training, which you can just go and access. There's no fee to do that. It's quite expensive to join if you want to be a SafeCode member, but the whole point is they charge a small number of companies quite a lot and then give away the results. And there's a lot of pro bono work done by people like security engineering teams, places like Adobe and Facebook. So what is the vulnerabilities list? Well, as I say, it's the list of things we keep getting wrong. About 75 volunteers, roughly, produced the 2017 list, and it's one of many projects OWASP run. OWASP run, I don't know exactly how many, but it's well over a dozen, maybe 2 dozen active projects at any time. Some of them are to create software, some are to do analysis, some are to produce reports and so on, and the top 10 is one of them, and it's a fantastic piece of work. The important thing about it, it started off being relatively anecdotal. Today it's quite data-centric. 24 firms gave them data this time, and that data represents 114,000 applications. So they're not looking at a few isolated data points in one company and generalizing. Most of the companies up there actually serve many other companies. So it's not Checkmarx's own applications we're very interested in. It's the fact that Checkmarx's tools are used by very many of the world's biggest firms, and in particular, many that are the most security-centric. So that's quite an interesting data set. Some of the data is available on GitHub. Some of it, well, in fact, it's all sort of on GitHub. Some of it is very obvious and easy to access in Excel, and others, there's various data files that if you're an R enthusiast, you'll have a field day. They then did a survey, because they wanted to follow it up with more of a qualitative view, which is this the right stuff? And from that survey, a couple of other very strong themes came out that weren't covered by the data, and they presumably argued internally and decided some of these needed to be on the list. So if you would approach this from a somewhat academic perspective, those of you with PhDs who will remember your research theory, this is a pretty sound process. They've done it in a pretty sensible way, and that's why I think the results are worth looking at. The top 10 in 2017, unfortunately, look depressingly familiar. I'd be surprised if there's much on that you go, really? I've never heard of that before. You're more likely to go, really? People are still doing that in 2017? Yes, at least 114,000 applications of them. So injection attacks are quite big. They've now stopped calling it SQL injection because there are much more creative ways to smash an application through injection. I'll get you to think about that in a minute. Broken authentication. Sensitive data exposure, so allowing data past controls without realizing you're doing it. And a new one for this year, which is XML External Entities, which we'll talk about the detail in a minute, but they're basically evil. Broken access control in general, that's people making mistakes in their access control system. After all, how many people have written an access control system in their applications? See, nobody else would admit it because you all know it's the wrong answer, right? It's very, very easy to get it wrong, and we keep getting it wrong, but we keep building it, you know? Getting security configuration wrong. How many security-related configuration files would there be in an average enterprise application? I have absolutely no idea, but it's more than one. In fact, it's more than 2 or 3. It's quite a lot. And even worse, in most organizations, there's different specialists understand each one. The guy who really understands the Apache web server security is probably not the same person that really understands the cryptographic configuration for, say, the .NET VM. They're almost certainly different people. So that is a major concern. Cross-site scripting, it's been there for a while. That's where we managed to inject something like JavaScript, for example, into a conference, a forum site, and we get someone to click on it thinking that they're going off to a news article, and they do go to the news article, but on the way, as a little added bonus, they get some JavaScript in their browser that, for example, uploads all their cookies off to a database so that somebody else can go use them. And obviously, if you actually think about it, just think for a moment, if you were going to create an insecure environment that's really easy to attack, particularly in a kind of subversive way, what kind of system would you create? So if you think about it for more than 30 seconds, you realize the modern web browser is not a bad place to start. Loads a lot of content, doesn't tell you what it's doing, it's very powerful, it's got several virtual machines built into it, is normally assembled from different pieces, and in most cases is blindly downloaded by end users with absolutely no check that they can trust it. As an attack platform, I think you'd be struggling to find a better one. So it's not surprising that cross-site scripting is still a major threat. A new one this time is Insecure Deserialisation. That is related to XML External Entities in a sense. It's sort of related to one of the others as well. Can't remember which one now. But this is things like Java and .NET in particular love a bit of serialization and deserialization, all built into the libraries, all a bit opaque and complicated, all kinds of possibilities there. Who uses open source at all in their systems? Okay. How do you know you've got no vulnerabilities in your open source? We'll move on. And number 10 is new this time as well, which is, this came from the community, where the community went, you won't be spotting it in the application scans that these huge companies are doing, but you know, the thing we keep seeing is people don't have logging and monitoring in their applications. I think that's a good call, because I think we've all worked on applications that actually, it's not even a security thing. They don't have enough logging and monitoring, but if you're a security response specialist, you're particularly concerned that you know that you've got a breach, you're very unclear where it came from, because when you went to look at the application logs, you found that almost nothing to do with security events was being stored for more than about 25 seconds, just long enough to debug something. As I say, these look obvious. I know there's nothing new on the list, but these came from the data. And that's why in fact, the fact you're at this session probably means in a sense you don't need it, because you're aware of this and interested in it. What you need to do is go back to your offices and become the security bore who keeps saying, do you know about XML entity, external entity injection? Everyone goes, no, but I think you're going to tell me about it. You go, yes, I am. You can thank me later. And actually kind of explain the problems to people. So what changed then? 2013's on the left. That's the talk I gave until this one. This is the first run of 2017. What changed? Well, the first thing was that cross-site scripting is actually less of a problem than it used to be. This is mainly because there's a couple of key browsers, and we have to thank Google in particular and Firefox, Mozilla in particular. They've really hardened themselves against cross-site scripting. In fact, to make so I run a more interactive session for smaller conferences. We actually sit there with your laptops, and you attack a vulnerable application called Matildae. And about 18 months ago, to my annoyance, Google have made it such that the Chrome browser won't allow my cross-site scripting lab to work anymore. So I have to go and put an entry in the PHP to disable that feature of Chrome. So, you know, that's a great thing. It's meaning that it's becoming hard to do trivial cross-site scripting. It's still perfectly doable. There were two in the old list that always confused people a bit. In insecure direct object references, that's things like allowing people to request an actual key name from a database in their URL, rather than a long random identifier that gets mapped in the software, and also having poor access control around functions. That they're both really quite related. As soon as you give a conference presentation on them, you realize they're awfully similar, because everyone says, didn't you just say that? So they've amalgamated those together. And sensitive data exposure, Facebook, but I'm only picking on Facebook. I've got, in a different talk, I've got a data viz of all of the data exposures, which I scroll up the screen, and it's absolutely horrifying. Like 2007, there's a couple of small circles on the screen, and as I scroll, by the time I get to 2017, the entire screen is blocked out of circles that are so close and such tiny text, you can no longer read them. That's currently the world we're living in. So obviously, that's pretty important. Security misconfiguration, for reasons I'm not entirely sure about, went down one. It seems to me that's possibly more widespread than XML External Entities, but clearly this went through a lot of peer review, so I respect their opinion. Cross-site request forgery, that actually dropped out, again because browsers are getting much better at not allowing JavaScript to do completely arbitrary things, which is great. And unvalidated redirects and forwards was really from the kind of previous era of the web. We're doing less of that sort of mod Perl type redirecting, rewriting your URLs, hurling it back at the browser, hoping for the best. It now tends to be done by software libraries via configuration, so it's less of a problem. So yes, sorry.
What's the difference between broken access control and security misconfiguration?
Broken access control is where you've actually got a flaw in the access control system.
Okay.
Security misconfiguration, in principle, everything could be secure, but because you're Apache guy and your operating system guy and your Java guy didn't all get their brains entirely aligned, you've introduced a covert channel or you've introduced a misalignment that opens up a vulnerability. So to look at these then, injection attacks, we all know about these. So the classic injection attack is on the screen. You've seen it 1,000 times before. MySQL, thank you very much. If you insist on expanding SQL in your code and not validating what people pass you and sticking stuff in, you will get attacked. And I'll show you an insecure application that does that before the end of the session. A new thing in 2017 are these little boxes at the top right. Obviously, the little box is mine. Thank you very much. But the colors, all of the useful stuff, which is the text and the colors and the numbers, are from the OWASP top 10. So what they've done is said, actually, people need a bit of guidance as to how important these are relatively. And so to explain the exploitability, how easy is it for a script kiddie to have a go at it? How often do we think we see them? How easy is it for it to be detected once it's being exploited? And finally, what's the technology impact of it? Are you going to have to rip out your entire tech stack? You know, that kind of thing. Yes?
You're missing a final single quote? Or?
I may be, because I copied and pasted this, but...
You need a final single quote.
No, so that starts a comment.
Yeah.
Yeah,
You
so...
still need the final single quote.
On what?
From where?
With the one from above, so %1 is
Yes.
now... I don't know, if you count the quotes, you'll see there's a missing final.
You may well be right. I will go back and look at it, yeah. I do have a working one.
Oh yeah, because if percentage 1 is replaced by quote something, it's going to be 3 quotes, and the example.
I've got an extra quote missing. Thank you for spotting it. I've given this about 6 times. You're the first guy to actually go, you're missing a quote. Yeah, that's either something you should be quite concerned about or extremely proud of. Now, but the interesting thing is that everyone knows about SQL injection. What are the other injection attacks in your systems? Right now, think about the systems you work on. What are the injection attacks? Forget the database.
Shell injection?
Absolutely, yes. Are you ever calling an operating system interpreter? If you are, you know, you need, obviously, goes without saying you need to be careful, but more than careful. Obviously, that's a generalized interpreter, which can do almost anything with the right privileges. You know, what other kind of injection attacks are there?
Languages which have an eval function.
Absolutely. Yes, exactly. Yeah, dynamic evaluation within the language. Story about that, when I was at Sybase, we didn't have dynamic evaluation in our SQL, and SQL Server did. And of course, we were direct competitors. At that time, we were still competitors. And it was really interesting. We got a lot of pressure from clients to put that in. And our first step was, the security engineering department went, "You're nuts. In the database kernel, yeah, really, we're never doing that." So we built something called the XP server, which was today we'd call it a microservices sidecar. That would be much cooler. It sat alongside the database kernel, and we fired our proprietary RPCs into it. And if they wanted to do something dynamic, they could load code into it. Still didn't like that. They still wanted to eval in the language. It was put into the language with great foreboding. The ability to, it was switched off by default. Admins had to switch it on. Of course, they all did. And then it was loads of security engineering went around it. Really clever people. It was tested, we thought, to destruction. Guess which feature had the most security vulnerabilities in the following 12 months? I'll give you a clue. Dynamic evaluation. It's generally not a good thing if you're a security engineer. I realize if you're an app dev, it's like really handy, but there's a trade. The other one that a lot of people overlook is configuration injection. Do you validate your configuration files when you read them? I put my hand up and go, I'm meant to be quite security aware, and I tend not to. After all, it's trusted stuff, right? Well, is it trusted stuff? Where does it come from? Especially today when it tends to be swept through automatically through a number of environments before getting to production, is there any chance that that could be subverted in some way? So again, with configuration, you're often passing data into quite a powerful interpreter. And quite often you'll have libraries such as the Spring Framework. As you can tell, I'm more a Java person than a C++ or .NET person. But the Spring Framework, for example, has a very sophisticated mechanism for expanding and processing properties, Java properties, which is lovely, except that, of course, if somebody passes the right stuff in, that means you've effectively got an interpreter. It's not just reading the data. It's going to execute code. Broken authentication has sort of expanded a bit in the last couple of years, but one of the new threats is, bear in mind, there are millions of credentials on the internet available largely for free, or for such a small amount of money it doesn't matter. So credential stuffing attacks is not, in a sense, your authentication being broken, it's not being aware of the real threat. The real threat is that there's like a 1 in 1,000 chance or something that someone's got a valid login for your system, especially if you're consumer facing, because people do use the same passwords again and again. There's also often well-known credentials built into systems, or if not built in, configured in by default. The Oracle database, now they have, to be fair, changed this, I think, as of version 11. But there used to be not one, there used to be about 8 logins that had standard passwords, some of them highly privileged. And so the standard thing that you always did on a VAX computer, showing my age now, was you connected to Oracle and you found out if sys/manager had been disabled or the password changed. And if not, you were in. Great fun. But that's pretty common. I mean, and there's an awful lot of open source stuff comes with examples embedded into it. Again, full of standard credentials. For good reasons, but if they're still there, not so good reasons. The other thing we do is in web-based systems, tends to be a webby thing, we obviously use session IDs because we haven't got persistent connections between the two. It's quite common to find applications that are accidentally leaving a session ID unprotected somewhere. Well, one, you can leave a session ID in the browser. You probably don't have a huge amount of control over that. Maybe you can obfuscate it slightly, but you've probably just got to deal with that. Though, of course, what's the problem there with a browser? What can a browser do apart from display your web page? It can run JavaScript that's been downloaded via another channel. And most browsers, that JavaScript has access to the entire state. I know the standard says it shouldn't, but in many browsers, it can read the entire state, not just the cookies for the current site. But the other thing is that people, pass session IDs around. So the obvious thing is you need to secure the link to the server with SSL, but then the session ID may be used in any number of places, and also frequently written into log files. How long do your session IDs in a web-based system last? That's a usability trade, right? I noticed, actually, we've just moved, so we use Microsoft for a lot of internal stuff. We've just moved some of our internal systems to use the Office 365 versions. I'm noticing that when I go back into my web browser, I'm still logged into Outlook. As an end user, I'm overjoyed. As a security person, my hair is standing on end, because that suggests that there's a very long-lived session there. And I would say for corporate email, on a laptop that's being traveled around with, that's not a tremendously good security trade-off. The other thing is that not rotating session ID quickly enough. If something goes wrong with it, it has to be invalidated immediately. As soon as it's finished, it has to be invalidated. So the mitigations are being aware that strong authentication is needed, being aware that there are many ways of attacking it, and being sure that session management is as tight as it can be, having that discussion with user experience people about, I'd like to invalidate the sessions halfway through them using the system, because that'll be really secure. We're not going to do that. Okay, how about every time they change state in the system? No, we're not going to do that. So the UX persons, how about we log them in once, and we log them out in about a year's time, because that will be really friendly. And it's obviously going to be somewhere in between the two. Sensitive data exposure has been on the list since the beginning, and this is where, in the old days of the web, this was before people secured links, before HTTPS, TLS became standard. But of course, the other problem with data is it gets copied around a lot, and it tends to be left at rest. And the two things that I keep seeing in systems is sensitive stuff in databases unprotected, because the database is seen as this hard, invulnerable shell. But of course, we know they're not hard, invulnerable shells. And the second thing is messaging systems. Do any of you work on systems that use messaging to tie all the bits together? So in my old world of banking, high volume commercial banking, wholesale banking, investment banks, that's what we do. Don't really do RPCs. We just broadcast messages right across the bank all the time, millions of messages an hour, link the systems together. You'd be amazed if you put Wireshark on the network, which of course you wouldn't, because that would violate your employee agreement. But should you do that, you would be amazed how much of that traffic is unencrypted, and also how much is written to disk files, either as spillovers or as logging or for debug or for shipping to another system. When you look at it, you think, that's quite sensitive stuff, really, to be kicking around in a file that's relying on Unix permissions to protect it, which is not a terribly strong permission. Obviously, the impact here is you can lose the data, but also if you lose stuff to do with credentials, then you can be attacked via your authentication system. XML External Entities is the new one. This is something where I was surprised to see it on the list, because I thought, who's using XML? And I thought, well, they've gathered this from data, so actually a lot of people are using XML. And XML External Entities are a sort of handy way of structuring large XML documents or DTDs. They allow you to decompose them, which is a good thing in a sense. The problem is that most XML parsers, I went and checked, and actually quite a lot of platform parsers enable this facility by default, I guess because they feel it would be confusing if it was disabled by default. People wouldn't know where to look. But the problem is that most XML parsers will blindly open whatever name is in that entity name, will read the contents and shove it in the XML file. So obviously there's a number of problems there. You can do an injection attack, but you can also do a denial of service attack by asking it to open /dev/random, because obviously that's not going to stop giving you data. So if you do that, the XML parser is just going to get bigger and bigger and bigger until there's an explosion. And then you've got quite a nice denial of service attack, because presumably, what's it going to do after that happened in most systems? Oh, we had an error processing this file. We'd better restart and read it again. And it'll probably read it again, at least several times. So. Access control is something that, on the one hand, is relatively simple to understand. On the other hand, if you talk to anybody in security engineering, is annoyingly difficult to implement. One of the problems with it is that it's one of those areas where theory hits the real world. I worked on a system for my old employer, UBS, for quite a period, and it was a large platform system that processed one of our financial products. And we'd ended up with quite a complicated access control system in it. And yes, we had written it ourselves, which was sort of fine, but anyway, let's move on. Let's just say that was fine. We'd written it ourselves, and it had become quite complicated. So, and it seemed to have lots of special cases in it. And we were quite concerned about it from an audit, control, security perspective. So we decided we'd re-implement that bit, and the business thought this was a great idea because they were always getting confused as to who had access to what. So we went through the normal software development process of making sure we're trying to do something simple to begin with, and then we involved lots of people, because we had people in every region of the world use this system. And in every job role, from trader and salesperson right through to back office person. And we talked to all the different groups about what access they needed. And it turned out not to be too bad. We said they obviously overcomplicated the old system. Actually, it must have grown bit by bit, because now we actually look at the security model. It's not too difficult. It's fairly simple and regular, and it's got hierarchies. And let's just implement that. And we put it right through, of course. We did a a period of user acceptance testing because we knew that we might have misunderstood people. So people who represented all the roles, we set them up with example security profiles, and in they went and tested it. And then we put it in, and I happened to be the on-call senior manager that night. What do you think happened? Got a call at 3 o'clock in the morning. Somebody in Asia, in Hong Kong specifically, was kind of upset because he now couldn't do his job because we'd broken the access control. What's particularly ironic was this person had been one of the expert users who told us all about the security. So we got him on the phone, and the long and the short of it was he was a special case. The conversation went roughly, I can't do this. That's right, you're not allowed to touch the Taiwanese trades. You told us that, you only deal with Hong Kong. Well, except when I need to correct an error, obviously, then I'll need access to the Taiwanese trades. No, that's not allowed in the model. You told us people don't cross geographies. Well, yeah, but apart from some of us in Asia, I mean, we're a bit different, we're special. You didn't mention that before. Well, no, we probably shouldn't have the access, but anyway, we need it. So I need to fix some trades in Taiwan. So can you just give me that in the system? I'll go back to the first part of this conversation. We can't do that anymore because you told us we didn't have to. And that was a really good example of security theory meeting real world kind of complicated situations. So it's quite, and of course what we did is we had to put an emergency fix in that night to give that user ID special access, and then rework the security model as quickly as we could and roll out an update to the system. Lovely. Not our proudest hour from a security engineering perspective, it has to be said. Part of the problem is it tends to be a bit fragile, and part of the problem is it's complicated because the real world is more complicated than we can possibly imagine. So kind of problems that people have with this is it's quite common to see people putting IDs in requests. So for example, a trivial one is something like an account ID or a user ID is being passed around in the cookie, and you can actually see it when you intercept it. We'll see one of those in the vulnerable app. And then you're asking for that to be changed. Now it's possible that on the server side, the server's going, oh, that's been changed, I'm not going to respect that. Or it might just go, oh, ID 26, jolly good. I've obviously checked that before, I'll just continue. That's quite a common security mistake in systems. And anything that relies on the user interface being trustworthy, this is quite a common mindset in application development generally. Well, we've developed the whole thing, so obviously the client is fundamentally trustworthy, so why don't we have the client create the credentials and pass them to the server? And as long as they're in the right format or whatever, we'll just trust them. Obviously. When you say it like that, it sounds ridiculous. And then you go to look in systems and you go, you're trusting the client, and if the client does anything, you'll trust it. And they go, yeah, oh, yes. Now you put it that way, that's a really dumb thing to do. Let's not do that. But it's quite common you see it. Yeah.
The first one about directly referencing IDs.
Yes.
Can you give some examples of some other patterns that you could follow?
Yes, it's mapping. It's not revealing an internal ID, which you would use for any kind of access control or access to anything, to the client, giving the client a surrogate.
Giving a surrogate?
A surrogate, yeah. So, the sort of standard security practice with cookies is don't pass over anything to the client about the identity, just give it a very long number, and then you keep all the stuff about this really means Bob on the server side. And obviously then that has to be secured itself.
I'm still slightly struggling. What's the issue? Why do you not want your asset ID to be revealed to the world?
Because the fundamental problem is that if you set that into the session once and then don't validate that it hasn't been changed, then something could change it. So there's a tendency to assume that because the browser's ours and it's our application, it won't tamper with the data. And of course, there's two problems. Somebody could get in the middle, but also somebody could inject something into the browser that does tamper with it. So for example, the kind of trivial example in all the broken applications is we authenticate you once, and then we put a user ID of some sort in a session in the cookies, send them back to the client, and the client puts that back into every request.
Sure.
And then the server doesn't say, is this really user 26? It just goes, oh, it's user 26, and it continues. And because the server handed the token out, it's assuming the token couldn't be tampered with, which of course it could be.
Yeah, I think there's two things there. There's the asset and there's the user. And
Yes.
My question is, what's wrong with revealing the asset ID?
I think because you're giving information away that the attacker will use to attack you, fundamentally. And if they can change that, then you have to be very sure you don't rely on the asset that's coming back.
Can I jump in? Because I think the example I really like
Please.
break it is that where you've got, I know you're showing there changing one URL to another, get
Yes.
to an update, but if you just look at the first one, where you get, if you change that 4567 to be some other number, if it's a thing that you're not supposed to see, does the code check the ID against you before it goes to get it? And
Yes.
So that's why I wouldn't want a real ID there, because it then means that whoever writes any code that deals with that ID has to also have a check-in to say, has the person really got it? And then someone else could write another function to do the thing. And
Bingo.
So,
Yep.
to me that would be the classic example of why not to do it, I think.
So
Yes,
you're
thank you.
relying on the security of your hashing algorithm?
Well, you can do a cryptographic hash. Again, it's a risk trade-off. I mean, I'm not suggesting that's totally free, but it's probably an accessible level of cost. Because all the examples you always find in the textbooks, if you like, they're always a bit trivial. But as soon as you look at your systems, because you really know your systems well, you'll see much subtler examples. Almost certainly. Then number 6 was the security misconfiguration one. The fact that rather than there being one place that you go and configure a single security model to keep an application secure, you actually get quite a lot of bits of information, and they all combine to create a security model that no one quite understands. So, if you go from the fundamentals, you've got hardware security, right up to you've got the security that's actually written in the application code. And solution architects probably, at least conceptually, understand quite a lot of it, and hopefully there are security engineers looking at the lot going, yeah, on balance, I think this is quite secure. Don't do that, don't set that on. But checking that it's all consistent and that it's all secure is difficult. And one thing that I see repeatedly is application teams, for no fault of their own really, is that they're using a lot of quite complicated technology, and there's a different security model in each, and expecting them to understand every detail and how it all fits together is quite difficult. So you're really relying on it all being secure by default. Whereas actually, quite a lot of it's not secure by default. So it's the kind of, if you think about it conceptually, there's a very complicated state there with multiple conceptual models, and there is an invariant you require over it to enforce the security. It's very hard for a human being to do that, and actually it's very rare to find a tool that will cross multiple security models. I think there are a few, but very few. And obviously one of the ways around this is automation, where we standardize and simplify as much as we can, and then we automate all the changes to the security config, having experts look at the stuff before it's done so that we don't delegate it all to teams and say, good luck, just stick it in your jar files. Cross-site scripting is the problem of where people inject something into the user's web page that causes it to behave maliciously, and so it normally then accesses another site. So it's a cross-site script. There's 3 main variants of it that they talk about in most of the books. I must admit, when I actually get into, I'm not a JavaScript web developer myself. I can write JavaScript, but I'm not an expert on any of this JavaScript front-end stuff. Every time I get into it again and I go into the real detail, I think, there seems to be an almost unlimited number of creative ways to embed stuff that's dangerous in a web browser. It's quite remarkable. But the 3 classifications that people tend to think about is you can have the reflected attack, which is actually you put the links in something you send someone and you get them to click on it, and then that does something malicious. So it's classic spoofing attack. But arguably more dangerous ones are where you store script in something that the user then uses in some way. The classic example is, can you get a bit of hidden JavaScript into a forum posting with a link that seems to help somebody solve a problem? Because generally, when you're on Stack Overflow and you're looking for a solution, you're in a hurry and there's quite a lot to look at and you'd like a solution quickly, you're possibly not at your most security analytical. And so somebody puts a link in that says, click here, it takes you to the Microsoft site to solve the problem. You click on the link and it firstly injects some JavaScript into your browser, and then takes you off to the Microsoft site to get the thing you wanted. You can also find this that people embedded in database records or anything really that's writable that the preferably the person attached to the browser, will be using, and ideally clicking on. The other thing is that is where devilishly clever JavaScript programmers will find ways of actually injecting JavaScript direct into the DOM. And I think there are a number of ways of doing that. Not being a JavaScript developer, I'm not really an expert on that, but they're sort of dangerous because they can sit in the DOM for quite a long period and then recognize events occurring and then take action based on those events. So such as I can inject stuff into your DOM when you're on a relatively low risk, or what seems like a relatively low priority site, and then when I see you move to a banking site, I can come to life and do something. So those are the really dangerous ones. That's why the banks are so keen now to have in-browser protection. Like, is it Interests? I can't remember who my bank uses, but they encourage you strongly, nag you all the time, to put a security plugin into your browser, which is specifically looking for this kind of attack and wrapping the communication with the bank. Key way of avoiding this, of course, is being very careful what you write into persistent storage. And when people do, this is why lots of sites, when you do postings, won't even allow HTML markup. And sometimes when they do allow HTML markup, they make quite a big fuss about it and say, you can only use B, I, and M, and I won't let you put anything else in here. And obviously what they're doing is they're scanning it for a simple pattern, and they don't want to get into complicated stuff about, have you got JavaScript? It's like, you can use letters, numbers, spaces, simple punctuation, and these 3 tags. And that's because it makes the validation problem relatively straightforward. The thing that they have to watch out about is things like URL-encoded JavaScript. So obviously, people who are doing this are quite sophisticated. They're not actually trying to post blocks of JavaScript. They're trying to hide the JavaScript. So they're doing things like URL encoding it so that it goes through all the security layers more easily. So again, that's why they don't allow percentages in blog postings. The insecure deserialization one is, oh, sorry.
About the
I will
last
go
slide,
back.
have you seen
Yes.
any Unicode injections? So I don't know if this is possible, but it just popped into my head. Because some older browsers may not fully support Unicode, they might
Good point,
just interpret
yes.
it as ASCII, but then the systems that are checking it do support Unicode and
Yep.
don't notice it. Have you seen anything like that?
I haven't seen them in my own security practice, but I've seen vulnerabilities in products in the NIST weekly vulnerability list, specifically about that, yeah. I think there's 2 vulnerabilities. One, using Unicode to hide data as it's being passed through, as you say, because the extended bytes just get ignored. And the second thing is that Unicode is itself an injection attack vector.
Yes. Okay.
Because it's an interpreter, in effect. So if you can get a Unicode interpreter to do something clever because you pass it encodings that are very unlikely, but actually perfectly valid, that aren't real characters, then you can open up vulnerabilities in systems.
Yes.
Yeah, anything with an interpreter. Yeah, it's a sort of good thing and a bad thing. Insecure deserialization is new. I'm not sure why it's new. I think perhaps this is as much that scanning tools are now getting better at looking for it, because it's quite a subtle attack. And I wonder whether the scanning tools are now better at spotting it, so therefore it's come up the rankings. Because the vulnerability's been there in the Java and .NET worlds since their VMs were created. I mean, they've always used serialization for RPC and storage and all those kind of things. So this is 2 major threats. One is, could you actually subvert the deserialization mechanism by passing it objects that, when they deserialize, have got a particular pattern of data that cause the application code to behave in an unexpected way? These have, I only discovered that in the last couple of weeks. These have got a new name. They're called gadgets. Gadgets sound such a cute and fluffy thing. These are not cute and fluffy. These are where security experts or attackers have gone through open source libraries in particular, actively looking for bits of code which seem to be interesting from a security perspective, and also appear that if the right object was passed in, you could circumvent the control. There are quite a few of them. If you search for deserialization attack gadget Java or deserialization.net, you will find listings of them. OWASP actually do maintain a bit of a listing, and there are some very, very common pieces of particularly Java open source, such as parts of Commons collections, which are vulnerable to it. So the idea is here that you pass it some data, you set certain fields to certain values, they get deserialized out, And then when that object is passed around the system, unexpectedly, you will go down certain code branches that, for example, assume you're administrator. They're quite subtle attacks. That's why this has an exploitability level of 1. It's both quite difficult to craft the objects correctly, and also you've got to know where the gadget is. So they're not trivial. But if you're in the secure systems business, this is the kind of thing that keeps you awake at night. Because if there's groups of people who can do this, it's nation states. They've got plenty of time on their hands, and they've got all the sophistication in terms of, for example, AI scanning. So they can use machine learning to find the gadgets. That's the real concern. And there's a general feeling in the security community, there's probably huge stockpiles of these so-called gadgets inside all of the government agencies that are involved in cybersecurity. Just the same way, there are piles of, as we found out through Snowden, there are piles of unexploited zero-day vulnerabilities inside major products, such as PDF readers and word processors and all those things. So they've almost certainly figured them out for enterprise platforms as well, which is jolly handy should you want to go and subvert a major enterprise's data storage systems, for example. The other thing that people can do is, I'll just come straight back, is deserializing actively hostile code. So this isn't some subtle thing that's deserializing normal objects and is influencing your algorithm. It's finding a way to do damage, and it's probably some kind of in the Java world, it's probably some kind of denial of service attack using the deserialized object. So obviously, if there are any flaws in the deserialization mechanism and there's a loop involved, then if you craft the right serializability bytes, then you can force the deserializer to go into a loop. It's that kind of actively hostile code as opposed to code that's trying to subvert the application level. Sorry.
You mentioned the Apache Commons. Some Googler kindly came along to my GitHub project and made a merge request to try and ensure that I no longer used Apache Commons version 3 point something.
Yep.
Because they did that as a sort of pro bono activity across GitHub.
Yes, indeed. GitHub themselves actually are running a couple of security projects right now. If you've got a JavaScript project, you may get the same. You may get notifications from GitHub. They don't actually give you the pull request, but they tell you what's wrong, and they tell you to go fix it. And Google and Facebook, to be fair, and other companies as well, I just can't think who they are right now, the big internet companies are being very good about this. They're putting their security engineering teams. I think they figure, we're going to get attacked. The less ability for people to attack in third-party software, the better it is for us, and better it is for the internet in general. So they're investing thousands and thousands of man-hours, and I think quite sophisticated, I call it AI, but you know what I mean, sort of automated scanning for vulnerabilities before the bad guys do it to you, which is great. On that topic, another problem in many systems is known vulnerabilities in components. Now, there's only been one major quantitative study being done on this that I'm aware of, and it was clearly done for commercial reasons because it was done by Aspect Security, a very respectable security consultancy. It was paid for by Sonatype, the Nexus people, who are a very respectable OSS-oriented company. However, clearly Sonatype are trying to sell an open source scanner, so we should be just cognizant of that. But there's no reason not to believe the numbers. This was back in 2012. But we actively run open source scanning ourselves on both our own and client code. I have no reason to believe that this has changed. I mean, the individual details have changed, but the trend, I don't believe, has changed. So firstly, there are some famous names on that. What this is actually showing is the number of downloads of that software, of those software packages that were downloaded after the vulnerability was known. Not before the vulnerability was known, after the vulnerability was known. The other detail I'd point out is that's a logarithmic scale on the left. I realize it's in light gray, but that doesn't mean that GWT is slightly worse than Apache Xerxes. It means it's like 100 times worse or something than Apache Xerxes. So something like GWT, not hugely surprising maybe, GWT is almost entirely a collection of interpreters. It's probably not the hardest situation, not the hardest environment to accidentally put security problems into. The one that really made me laugh, though, was Bouncy Castle. Does anyone from a security background recognises Bouncy Castle? It's probably the best known and most respected open source Java cryptography package. So, if they've got a problem, I think we can all be humble enough to say we might have a problem too. They do not, they're doing. It's like the day that Hacking Team got turned over. Those of you in the security community probably chuckle as much as I did. Hacking Team were still are under a new name, company that produce hacking tools, really advanced leading-edge hacking tools, mainly for governments, and aren't too fussy who they sell them to. So they're not the most popular people in the security community. They sort of give attack tools a bad name. They got turned over by Anonymous, or whoever Anonymous were, on that particular day, and got all of their internal data pulled out of their organisation and published on BitTorrent, which I would personally view as a public good. But I don't suppose the people at Hacking Team saw it that way. Same thing, though. Those people knew what they were doing. They're really at the edge of the security industry in terms of capability. When they can get turned over, we can all be humble enough to consider it could have been us. So, those are famous names in open source. They're not written by amateurs or idiots. It's easy to put security vulnerabilities in. And the thing about open source is, one, those projects tend not to get a lot of security attention just because of the way that they're produced. They haven't got security engineers paid to go look at them in general, unless they're lucky they've got a corporate sponsor who's come along and said, I will help you with this. Generally, they haven't got a security engineer. Second thing is, if you buy a product, so back in the day, I was a C++ developer, and I used RogueWave a lot. And the RogueWave utilities library is fantastic. One of the things about RogueWave, they were very good at being very proactive about defect management. So, and I was at Sybase, we were shipping product with RogueWave in it. We licensed it and sent it out. The thing we could always rely on is, if there was a problem in the RogueWave libraries, we'd know about it really quickly, and we could do something proactive. The open source folks can't possibly do the same thing. They haven't got the same connection with their customers. They don't know who's got it. So it's much more our responsibility to know what we've got and know if there are vulnerabilities in it. So it's much more difficult. And I don't say this is a criticism of open source. It's just an inherent trade-off in the model.
I would also say you're very lucky with RogueWave.
Right, good.
It's just that my experience with commercial, with a commercial component, our industry, was that they kept very, very quiet.
I've had that too, actually. I won't name names, but there was, at a big bank I worked at, I won't name names, there was a large supplier of middleware and system software products. I'll stop there. And we were always told we shouldn't use open source because of the level of support we got from the vendor. We had a major production incident to do with garbage collection, damn all for 3 weeks. Really, I mean, that was the idea, that was commercial support. So absolutely, I mean, I very much varies by vendor, I think. So, lots of things have vulnerabilities. If you want to scare yourself, subscribe to the US CERT weekly vulnerabilities list. Monday morning, get a cup of coffee, have a scan over it. Absolutely makes your hair stand on end. And that's the commercial stuff mainly. That's people who are paid to create it, to make it secure. So the open source guys, you cannot possibly expect them to be secure all the time. Most people I've found use open source, and actually when you ask them the question, there's a bit of an awkward moment where they go, I probably should have thought of that before now. Because it's just not a common question people ask each other. The only real mitigation is you're either very, very diligent and you follow the mailing lists and you set up alerts and you're very, very careful, or unfortunately you pay money. And there are companies who are doing quite a good job of keeping on top of this for you and providing automated scanning tools. But those cost real money. I mean, we do invest in one in Dava, which doesn't matter which one, but the point is that that's a significant commercial investment we have to make, which, again, all these things are trade-offs. And finally, insufficient logging and monitoring. This is the community one where a lot of security engineers are going, it's a problem to have vulnerabilities, but you'll have them. However, to not know you've got them and not know how it happened, that's really not okay. It's things like not logging all the security events or getting rid of logs very quickly. It's things like having poor messages that something's gone wrong without anything actionable for anybody who didn't write that piece of code. And it's also piling up logs. I've seen this quite a lot. People pile up logs and they aren't quite sure what to do with them. There's sort of no point having the logs unless you can do something with them. And fine-grained logging produces so much data, it's almost certainly going to need automated solutions. Nice suggestion actually from OWASP is they produce the OWASP attack proxy, ZAP. If you run that against your system and you don't get some alerts, go back and look at your alerting. If you run attack tools in your system and it's not very obvious they've been run, then they're pretty brutal. It's pretty obvious when you run attack tools. Real adversaries are quite a lot subtler. So if you're not getting alerts from the attack tools attacking your test system, you definitely need to go and think again. Yeah.
Well, all of our systems are always under attack. I If it just tail auth.log, and we're all constantly being attacked, we don't really care about the attack, we care about
the mitigation. Yeah, absolutely. Yeah. Yeah. Well, I mean, that's probably the right thing. In fact, so, yeah, I mean, I guess we all are. I mean, I've got a little DigitalOcean VM which sits on the internet, just got port 22 open, hasn't got a proper DNS name, just one of the very long DigitalOcean ones. I've got my own alias. There's nothing valuable on it, seriously. If you're thinking of having a go tonight, be my guest. There's just nothing on it. It gets attacked up to 1,000 times a day by automated password brute forcers. It's quite funny. I do collect the logs, and just for academic interest, I pass them through a little log analysis script I've got. So when does it get attacked and where from and all those things. And you will not be surprised to hear that a lot of the attacks, the geo lookup of the IP is in China or Russia. Not a huge surprise. The thing I thought was quite rude, though, about number 8 or 9 was the UK. I thought, I mean, honestly, I can sort of cope with being attacked by China, but being attacked multiple times a day from the UK just seemed to be rude somehow. So go and attack someone else. You know.
Can I
Yeah.
that one? So if you had attack alerting on, you would be getting those 1,000 alerts a day.
Yeah, that's why you would find you're alerting all the time. So
how do you get alerting that is kind of, as it were, useful?
So that's a constant refinement process. So you start off, and on day one, you probably do just get everything red. And then you figure out quite a lot of these are not useful in the sense that, yes, something's happening, but we have perfectly good mitigations there. You might pile them up and just take summary statistics off, because it's quite interesting to know, is the attack level going up or down, those kind of things. Are you becoming more or less valuable? Are they getting better or worse? But you filter those out, and then you see what you're left with. And at some point, a security engineer might go, actually, I'm a bit concerned about that one. There was an awful lot on one day and nothing for a week. That suggests they might have been successful, and they might be in. So that's I think, how you do it. It's a little bit like when you do, I guess, database tuning. You know, there's an awful lot of things you look at initially, and you throw a lot of it away, and you go, actually, we've got a problem with this index. And then there's quite a lot more to do, but you throw away a lot of your initial findings. So the summaries of the types are: watch out for interpreters and watch out for injection generally. Validate everything, because the world is not a trustworthy place, sadly. Make sure the data is protected, not just with SSL, the number of times. How many of you had a conversation with someone about security and they go, well, I'm using TLS, I think I'm secure. Quite a common application team response. Data needs protected according to its sensitivity and the threats, but you need to consider everywhere the data is. Really secure systems, those of you working embedded, maybe actually encrypt data in memory. And that's perfectly reasonable if they think they could be attacked by, for example, service personnel attaching to the hardware. Most enterprise systems, that's not a good trade-off. And finally, complexity is always the enemy of security. That's a Bruce Schneier truism which has been around for many years, but it's not changing really. Software keeps getting more complex for good reasons, because we're getting ever cleverer at what we do with it, but every time there's some sort of trade-off for security. So some of the tools that you might find useful. There are some deliberately vulnerable applications, which sounds like a strange thing, but actually they're very useful because they're sort of obviously vulnerable, but it shows you how easy it is to attack them and gives you some ideas how people might go about attacking them and gets you to think about more subtle problems in the same domains which you might have in your systems. Quite a number in PHP. I use Matilda personally. It's an OWASP project. It's a PHP MySQL LAMP type thing, which is deliberately insecure. Most of them have got different modes. Matilda's only really got two. One is it's very hackable, and then it's got this is not very hackable. And in fact, if you get on what they call level 5, they actually want a bug report because they'll go and fix it. So that's sort of the point is you start with a very hackable version, and then you sort of think, right, so I can attack it this way, I can see how that works. If I make it a secure web application, would that attack in principle still work? And there's also a very well-known one now in version 8. It's a venerable application called WebGoat, which is really a whole tutorial, actually, about web security written in Java. And obviously, if your stack is Java, it's better to learn or to go and look at WebGoat because there's more details to learn. There's also down the bottom, there's a thing called the Pen Test Lab. That's a set of scripts for building Dockerized versions of them and for handling. It allows you to boot a whole lot of them on the same machine and start and stop them with different names. It's quite handy. It's just a packaging thing. Burp Suite, if you've not come across it, is the security analyst's standard intercepting proxy. It's a commercial tool. It's actually created in Knutsford, believe it or not. It's a British tool, which a lot of people don't know because it has global reach. It's known right through the world. It's a great British export success story. It's produced in that building there in Knutsford. They create a very capable free version. Just if you're actually a security tester, there's quite a lot of tools which they say, you click on the tab and it goes, you'll be needing the commercial version. So we actually buy it for our security testers. It's £275 a year, I think. It's pretty reasonable. But the free version will take you a long way. The other thing you will need, sort of obvious, you'll need something in your browser to allow you to change proxies quickly, because obviously the way Burp Suite works is it's an intercepting proxy. So you'll want a way of sticking a proxy in quickly. And a tool which is really interesting, and for me this is a great example of weaponizing quite sophisticated attacks, is SQL Map. SQL Map is sort of the industry standard for how you go about establishing if you've got vulnerabilities in a web app with a database behind it, or the database itself. I'll demo it now, actually. It's written in Python, and it's frighteningly effective and sophisticated. Let me show you a bit of it. Oh, and Metasploit, sorry, is... Metasploit's slightly controversial. Whether it's actually an attack tool or a pen tester's tool is something of a debate, but there is a bit of a grey area in between. Particularly because Metasploit's got stealth modes, for example. It's very easy to do real attacks with Metasploit. There's a lot of warnings on it saying, if you're caught using this the wrong way, you are probably going to be in deep trouble. You can't help but feel, if you wanted to attack something, you could start in many worse places than Metasploit. But it does mean for pen testing, it's very handy. It's got a lot of tools and a lot of attacks. It's got a very active community around it. And there's also Kali Linux, of course, which I don't have on the slides, which is a Linux distro with all this stuff in it by default, and it's all pre-configured. The other tool, just to mention, is this open source scanning stuff. I'm not selling you any commercial products. There are quite a lot of them. Well, I say quite a lot of them. There's about 5, maybe 6. The 3 that I think are probably best known are Black Duck, who, to be fair to them, largely defined the market when they came into it. White Source, who are a smaller Israeli company, who do a product of the same name, a SaaS-based product. And Sonatype, who, as well as Nexus, produce something called the Lifecycle Manager. And one of LCM's major roles is open source scanning. And certainly Sonatype, if you talk to them, they believe they've got some very strong very detailed technical differentiators. Arguably, they will produce less false positives, especially on security problems, than the others. But all of them are capable. We've evaluated these in the last couple of years. They're all very capable of doing a good job. But they all cost money. And of course, what you're paying for, I was challenged whether we could build one by some of our execs who, very fair question. It's open source, right? You're paying money? It seems a bit weird. You're not really paying for the software. You're really paying for the database. It's the database is expensive to build and modify, create, keep up to date. The software is not that hard to build. We had a look at that, and we were trying to work out, could we staff a security center in one of our delivery units that would sort of do the same thing, and maybe we could do it for clients, and it's a big job. Those are expensive databases to build and keep up to date. So the thing that, I've got 2 things I can show you. One is Matildae. Matildae is this vulnerable application, and you stick Burp Suite in front of it, and then in your browser you go off to Matildae, and Burp Suite allows you to attack Matildae in various creative ways. The thing to mention about this is that a lot of the attacks look very simple by themselves, and it's true, they are simple. They're normally not used by themselves. Adversaries don't just do one thing and stop. The adversary's normally got a goal in mind, and they will often take many, many steps to get to the goal, which is why what seems like quite an innocuous attack simply for them is one small step on a journey. And you think, well, if that's all they're going to do, what's the problem? Except actually they've got one small extra bit of information which allows the next step. And eventually they'll get there. So, they do an SQL injection attack and you lose your user list. I didn't have any passwords in it. It doesn't sound like a big problem, except that actually then allows them to work out who to target. So they target some XXS into their particular blog entries. Much higher probability the person they want will click on it. And then once they've got that, they will then send a link to an administrator to try and execute that script because they know who they're targeting. And then after that, that JavaScript will run and they'll steal the browser state. Actually, the funny thing was, they weren't remotely interested in your site. They're actually trying to attack eBay. So they've actually stolen eBay's token. It's not your risk, it's eBay's. But it was your site they used as the jumping off point. And that's not a complicated example, I realise, but the point being, any one of these is the level we're talking about here. They're not the point. The point is that strung together in creative ways, ever more creative ways, that's what really forms the threat. So we'll talk about defences in a minute. Just show you SQL map, because I think it's a reasonably instructive process. So I've got, can you see that? Oh, you can't see it at all, no. So I could start messing around with the screen config, and we could all be here all evening, or I could just move the terminal. There you go, you can see it. The only problem is I can't see it, but I guess that's just a detail, really. That's very impressive. What will that do? Mirror my screens? I will try that. Yes. Brilliant. As a man who does more conference presentations than I do. Thank you, Seb. Lifesaver. So, can you see that? I guess if I made it a bit bigger, that might help. So I've got Matilda on this machine. Doesn't really matter how it's running, but I'll show it to you anyway. That's Matilda, the vulnerable application. We don't really have time to get into a demo of that, but we might do one simple attack in a minute. But what's more interesting is SQL map. So this is the Python script. I've done nothing clever. I've downloaded it, and I've got an application which has got a vulnerable web front end, and it's got a MySQL type backend. But the MySQL bit's not that important, because what I did was I simply ran SQL map. And here it is. Oops. Definitely didn't want to do that. Don't know if it's done now. Let's go back up. So I ran this because it takes about 10 minutes to figure out its initial way in. But it's quite bright. It captures the state. It knows what vulnerabilities it's found. It acts just like one of those humans. Every step it makes, it records what the attack vector was, and then it can retrace its steps. So it's much quicker then. Because after all, if you're going to attack a website, you don't want to waste time, right? Time is money. So that's all I did. So just to go over it. So I've had to give it a bit of a chance. So I've had to say, well, there's the URL to a page. And I've got some parameters to that page. Now it can work that out, but actually that takes absolutely bloody forever. And I find that bit often doesn't work so well. So I give it a chance, and I say, here's the fields on the page. I suggest you have a crack at those. And I tell it also, and I tell it at the end, what I'd like, if you can get it, I'd like you to list the databases inside the database server, which I know nothing about. I don't know what kind of database it is, but I'd like you to list the databases at the back. And the quite remarkable thing is that it starts running, and then you go and make coffee or something, and it chugs through. It tells you quite a lot what it's doing. It says, oh, actually, I found that page variable isn't injectable. That's a shame. I'll move on and do something else. Oh, it might be vulnerable to XXS. That would be handy. I tell you what, I should probably find out what kind of database I've got. So I'll see if it's MySQL, and I'll do what's called a Boolean-based blind test, and then I'll try an error-based test, and then I'll have a look for Postgres. Could be Postgres. Could be SQL Server. And it'll try them all, because it could have false positives. It could be Oracle. MySQL again, Postgres. It's going through trying to find out as much as it can about the database server. It then figures out that that username sadly isn't dynamic. Well, that's a bit of a shame. But it's got to its first checkpoint here, and it says, well, I think the back end is MySQL. Do you sort of trust me, or shall I keep on probing for other databases? And you go, no, it's fine. I'll trust you, it's MySQL. And then it says, given it's MySQL then, you've got the risk level set at 1. That's effectively how brutal it's going to be, how likely you are to be detected. It says, shall I stay at level 1, or do you want to go all out? And I've said, go all out. Why not? So I've said, no, you continue. I said, righto then. Well, I'll start running MySQL. You have another cup of coffee. I'll keep on running MySQL tests. Note that I started this at 10:27. And this has taken until 10:32. With no knowledge of the system to work out that it's running against the MySQL. That's not bad. That's sort of industrialization of hacking, really. I don't think a human would have got there faster, even if they'd been an expert. and then it has a look at the various fields, and then it starts thinking about MySQL as to how it could attack it. And it's got various patterns for the attack, which get updated all the time. That's the nice thing as well. They keep on making sure the vulnerabilities get updated. It's just like having commercial software. And then it does some other checks, such as it checks how the union attack is a very common one with SQL injection. If you think about it, if you've got a query and you can add unions to the bottom, you can add lots of other tables to one query, and then you can get it, what you think is an innocuous query on a very simple table. If you can add stuff to the bottom of it, you could go to much more sensitive tables. Now you see why partitioned access control inside the database is a good idea. That's a key one, which takes quite a long time to run. And then it says, well, I've got good news and bad news. Good news for you, bad news for the person who owns this database. I have discovered, I used 252 HTTP requests. That's why this is real industrialized. I mean, a human would take a long time to go through that process. It's taken 7 minutes or something. I've discovered I've got loads of different ways in, so I'm going to use one of those. And you said you wanted databases. Well, I've got the database names. How about that? And then you see, it's now not going to take 7 minutes. What we can say is, why don't you go and look in the OWASP database and find me the tables? And it will start running and say, well, you see, I kind of know what I'm doing now, so I'm just going to go straight back in the way that I did last time. That'll be much quicker. It won't be instant. And this being a demo, it will now hang. We can be almost certain of that. And it's, oh, no, we got in, and we've gone off to the OWASP database, which was very straightforward for us. And now we're going to fetch the tables back out of it. It's quite a slow process, of course, because it's not actually running queries against the database. It's subverting it through a web interface. I haven't given it the connection information for the database. It has no idea how to get there. You can also do that. That's far quicker. It just attacks the database directly. We've got the tables. That's super. So if we said we wanted to have a look at the credit cards table, I wonder what's in it. And again, it's not going to take a lot longer because, again, it sort of knows how to go in now. And it's got all the information it needs to go right to that table. And it's, again, running lots and lots of queries. Which, incidentally, Burp Suite is logging for us, just to show you Burp Suite. So if I go back off here at the front, this is a running log, oops, of all the stuff this is doing. I don't know which end of the list I should be at. Oh, no, 1718. It was down the bottom there. Well, so this is, I probably can't see that, it really is small, but that's an example. The user agent here is SQL map. So I can tell that it's SQL map attacking. You don't need to do that. It's got a very handy command line parameter called ---- random agent, where it's got a file of all the agents that are currently credible, and it just rotates them. So I don't switch that on because I like to know that I'm being attacked by my own bot. But clearly, if somebody was to use this for nefarious purposes, their argument is, we've got to give you all the tools the bad guys have, otherwise you don't know if your defenses are valid, which is a perfectly valid argument. The other side of it is, this is a very effective tool for weaponizing SQL attacks. So I wonder how it did. Yeah, so there we go. So we've extracted our credit card table. It's such a shame the CVV numbers weren't encrypted. That's actually, of course, breaking PCI DSS guidelines for all of you credit card people in the audience, but it's not that realistic. But that's just, so firstly, I am not an expert on either SQL hacking or SQL map. I use it casually, maybe 6 times a year. You can see how easy it is. So pretty well anyone can attack a vulnerable web application and get into the database.
This is attacking an HTML page.
Yep.
Can you do REST with XML payloads? And
Don't think it can at the moment. That's something that they might be working on. The reason I say they might be is because they have or used to have something that could deal with, I think, XML requests, so SOAP-style requests. Now, I don't know if, I haven't looked for a while. That might or might not have been developed, but I'm sure it's perfectly possible. The reason that they do it with HTML, I think, is because the vulnerability, the attack surface is so much richer.
Okay. So we're attacking utility here, and it's running it as most insecure.
It is,
so,
yeah.
I mean, is that trivially insecure, or is it It's,
level that you might find in
it's at a level that almost any competent attacker could break. I know, though, from running at the SPA conference, if I give it to you with Burp Suite and good hints, but I don't tell you what to do, you won't break in quickly. 1 or 2 of you will get lucky, but in general, out of a group of 10, 1 or 2 will get in without me showing you the actual solution. So it's, yes, from a security engineer's perspective, it's got pretty gross errors in it. In terms of, can you literally walk up into it and just break it by playing with it? No, it's not that insecure. So, and it's a perfectly valid point, though. Obviously, I do this demo kind of for laughs, really, in that I am using an insecure application. The point is that you can see how quickly it can run an awful lot of, and I'm not parallelizing it either, it can do an awful lot of requests on a system. Therefore, a more secure system can spider and find it quite quickly. Somebody who's a bit determined, Burp Suite can also, for example, spider the whole site for them and give them the set of attack URLs to use, which they can then plug into this. So there's a lot of weaponization, if you like, which has been done on quite sophisticated attacks. And that's the concern. Oh, sorry.
Regarding the question about REST, are you aware how easy it is to add another protocol specification to it, GraphQL, for example?
Do you mean SQL map?
Yes.
I don't, because I don't know much about how it's written. I have poked into the Python, but it's non-trivial amounts of Python, so no, I don't really. Though they're very, if anyone's a Python person who likes security and databases, they're always looking for people to contribute. Sorry.
On SQL map, does it tell you how it got in? So it says, ta-da,
Yeah.
Does it log out, like, and here's the steps I followed to...
Yeah, pretty well. You can pretty well recreate it. It's got, it creates a .sql map directory, and under that keeps records of everything it's done. It uses that for itself, actually. It's not necessarily for you, but yes, you can read it.
So what I really mean is, how clear is it how to fix the bug? You can see that you've got vulnerabilities.
It's clear where the vulnerabilities are. It's not entirely clear necessarily what to change in the code to fix them. You know where to go look, and I think at that point you either need an expert or ideally, maybe that's someone to go and scan again with a vulnerability scanning tool. That it just hasn't been done or someone's missed something. So how do we actually defend ourselves very quickly? The key things are, don't trust browsers, don't trust clients. Servers have to be inherently secure. And I know that's sort of obvious, but when you've written all the stuff in the browser too, you sort of think of it as a joined up whole. Interpreters are generally quite dangerous attack vectors, and they keep being so for every generation of them that comes out. So, Unicode, which I'd completely forgotten about, was a great example of one that, it handles character encodings, for goodness sake. How dangerous can that be? Just go and search the CERT database. It can be quite dangerous. We all forget about valuable information at rest and in transit. And we don't always forget. Sometimes we decide not to do it. And why do we decide not to do it? Because nothing's free. What's the trade-off with encryption? Well, there are many, but the 2 big ones, computational overhead and key management. Key management is a non-trivial security problem, as anyone who's tried to do it will attest. Yes, you're more secure, but if you don't do your key management right, it makes absolutely no difference because your keys can be breached. Simplicity is something security engineers are always driving for. In fact, security engineers would just like us not to write any more software, please. That would really be a good outcome. But obviously, the more complicated, as we've seen, the more complicated something is, the harder and harder it is to know that it's actually secure or to make any kind of rigorous argument. And finally, I'm a big believer in standardizing stuff as much as we can and automating it. Clients, sort of said, but key thing is that we don't control the client, even if we've injected the code into it. It's in a potentially hostile environment, and so it can be directly manipulated. There's lots of kinds of interpreters. The key thing is not to get too hung up on SQL injection, I think. It's not that that's not a risk. It's just that there's lots of other ones too, and that's more where I see the problem. And the thing is that someone's going to figure this out. There are people out there with time on their hands, and or even being paid to do it. Did you want the previous slide?
Be posting these online? Or?
I will, yeah. I will submit the pull request I've been requested to do. Yeah. For valuable information, you've always got to assume that the perimeter's been breached. In fact, there's quite a big movement in security at the moment to to change the way we think about this. There's been historically, especially in enterprises, an assumption if you build strong enough walls, you don't need to worry too much about security on the inside. People will generally do the right thing because they're under contract. There's now, I think in the last few years, people like, well, Ashley Madison, hacking team, Sony, I mean, all of these people being breached, I think has created a new realization. You will be breached, so therefore you better more think about things being secure, assuming there isn't a secure perimeter. Yes, it's nice to have a perimeter too, but you've always got to assume that that's been broken. So the defense in depth argument, which we've always used, has just become that bit more important, I think. And of course, encryption, as we were just saying, complicates everything, unfortunately. So that can, ironically, become a source of security problems itself. So again, that's somewhere where you've got to think about it quite carefully. And simplicity and standardise, as Schneier says, if you don't understand it, it's definitely not secure. So therefore, it's got to be simplified to the point where we can have a reasonable chance of understanding it. I realise with software, there are so many abstraction layers. Understand is a very relative term. But if you don't even have a really strong theory of operation, it's very hard to secure it. And then simplify, standardise, automate. If we can standardise the way we deploy things, if we standardise how our security mechanisms work, if we automate as much as possible from development right through to production, we are less likely to put in those subtle special cases that typically result in security breaches. So in summary, unfortunately, most of the stuff we use is quite insecure most of the time. And that is actually the world we live in. So as application builders, we need to be thinking about mitigation right from the beginning of creating applications, but right through the life cycle too. It's definitely not a big upfront design type exercise. It's a little and often constant refinement game. Attacking systems, as I've just demonstrated with SQL map, is becoming industrialized. That's a very mainstream white hat tool. There are plenty of much more sophisticated black hat ones out there. So people with relatively low skill levels and low commitment levels can now attack systems, therefore they will. The really interesting thing is we're not getting a lot better at it. As the OWASP top 10 keeps showing every time they republish it, there are some fundamentals that unfortunately we seem to find very difficult to address. It's interesting to consider for a while why that must be, but we're very good as an industry at learning about some things. It appears security threats or security vulnerabilities is an area we're not very good at learning about. So that's why the OWASP top 10 is still worth talking about in 2017 as it was in 2002, because it is real. And the other thing to bear in mind is that individual vulnerabilities may not look in themselves very valuable. Always remember that attackers work in many, many steps. If you read the detailed post-mortems of things like the Sony attacks, when they finally figured out what happened, it's many steps. There have been some, actually, I can't think who it was now, a company recently published a really good post-mortem of how they'd been attacked, and people did get inside their network. I can't remember who it was, and they were a really good security company, and they published a brilliant post-mortem, which just showed that it's many months of patient effort gets people in, which is why as app developers, we need to just assume the environment we're in is not necessarily friendly and cuddly. And a lot of the mitigation is not terribly hard. What's hard is applying it all the time, because it's something it's easy to do a blitz and then forget about it again. What's hard is to make it part of your day-to-day security, your day-to-day software development practice. So security is not their problem, or it's not a once-a-month thing. It's just part of how we develop software. In the same way that something much more trivial like naming variables is just how we do it. We do it every single day. We've got to also think about things like security every day. Quite a lot of books in the field. What's interesting is that a lot of those books aren't new. If the newest one is the one on the top left, has anyone read Shostak's book? Threat modeling is the process of finding out how people are likely to attack your system, hence finding the most important vulnerabilities. Adam Shostak worked for Microsoft for about 5 years. You may remember Microsoft some time ago had a terrible reputation for security. Shostak was one of quite a big team of industry experts they hired in to solve different parts of the problem. And he ran threat modeling courses for hundreds of Microsoft teams all over the world. The result is that book. And it's a really, not exactly straightforward, but it's a really practical, results-oriented, non-theoretical approach to doing threat modeling, which is refreshingly good read for a security book. The other ones, I won't go through them all, but security engineering is Ross Anderson's book. Ross Anderson is professor of computer science at Cambridge, major guy in the security engineering field. His book is again now some years old. Most of it is still completely relevant to what we're looking at today. And so because those threats aren't going away, don't necessarily discard books because they're a few years old. Whereas if you're looking at framework programming books, 3-4 years, they're no longer relevant. Security books, they tend to have a good shelf life. So that's all I had. Thank you very much for coming to a security session at the end of the day. I'll be around this evening.